Right. In this video, I wanted to give you some tips about your trig graphs. So first of all, that is a picture of the sine graph. And with your picture of your sine graph, you know that you always are starting at 0 unless there's a phase shift of some kind or it shifts up and down. But it should look like it starts at 0. It usually has a midline. And then from that midline there, it's where you count your amplitude. And your amplitude is the highest, the distance between the midline and the highest, or the midline and the lowest point. So you notice a traditional sine graph without any amplitude change goes between 1 and negative 1 and 1, really. And then you can take and you can change the amplitude. So remember, the amplitude makes it makes that distance in between the midline and the highest and lowest point bigger. And that's really the biggest thing. And we could also change it and shift it up or down is really one of the bigger things that we might do with it. And then remember putting a number, if we put that number in parentheses, that does what we call a phase shift. So it shifts it to the left or the right. And whatever you can do with sine, you can do with cosine. So let's look at a cosine graph really quick. The difference between sine and cosine, let me put them both up there, actually, y equals sine x. So sine starts at 0, cosine starts at 1. So I like to think of it as sine starts low and cosine starts high, and that's how you tell the difference. The amplitude is still true. It's still from negative 1 to 1, and it's still from the midline. I can also put the make the amplitude higher or lower. If I made it negative in front, it's just going to flip it down. So instead of starting high, it would start low and not at 0. So, but low, and then again the phase shift I could just add to it, but I add inside. Ooh, that didn't take it very far, did it? -2 maybe. Okay. If I am outside the x, it's going to shift it up or down, just like we've learned with every other parent graph this year. Then there was cosecant and secant. So we know that cosecant is the reciprocal of sine. So if I was graphing this by hand, I would actually draw a sine graph and I would flip these u's. But we need to know, we know that there's places when we're on the unit circle that cosecant is undefined. So if I looked at those places, so x equals 0 is one of them, x equals pi is one of them, x equals 2 pi is one of them. And you'll notice that those values are the asymptotes in between where those flips are occurring. Those are also the zeros where on the x-axis where sine is crossing. So if I did that exact same thing for secant we know is the reciprocal of cosine. So I should flip a cosine graph. Notice those asymptotes don't work because, so it's the same u flipping. And those asymptotes don't work because that's not where cosine is undefined. Cosine is undefined at pi over 2 and 3 pi over 2. And let's see, 5 pi over 2. Let's try that. 5 pi divided by 2. And we've talked about the fact that the unit circle, you can keep going around and around and around and around. Something called periodic. Well, periodic means it just kind of keep going. And so this is one full period when it goes from a top to down up to a top when we do one full wavelength. And you can keep repeating that period over and over and over again. And that's kind of that connection. The unit circle can keep going and going and going and going. The only other two that we had left were tangent and cotangent. So tangent, and these ones are kind of fun because they kind of look like the heartbeat monitor. They at least used to, but on the older graphing calculators. And again, there's asymptotes in these. There's asymptotes when tangent is undefined, and tangent's undefined at pi over 2. Oops, not that. X equals, so at pi over 2 and at 3 pi over 2. And so on and so on and so on. And then cotangent Looks very similar to tangent. In fact, let's put them up there together. Y equals cotangent of x. So they're very, very similar. It's just there's a shift. See how the tangent, the asymptote is at pi over 2, but I'm going to take that one off. The cotangent's asymptote is at 0 and at, and at pi. So because of that shift, I left that one on. I didn't put it. Oh, so x equals 0. There we go. So 0 and pi is where that cotangents asymptotes are. So it's the asymptotes where you can really tell the difference between tangent and cotangent.